Today I'm going to explain you how could we solve this problem single element in a sorted array. This is another problem from Leetcode's May challenge. Let's read the problem statement here. You are given a sorted array consisting of only integers where every element appears exactly twice except for the one element which appears exactly once. Find this single element that appears only once. So for example, here as we can see, all of the other elements appears exactly twice, only 2 is appearing exactly once, and similarly here we have 10 as the only once appearing element. So it also is given that we should devise an algorithm which runs in O log of n time with constant space. If this was not given, we could have just run through our array taking XOR of each element, and the final XOR of overall array would have given us the answer, because the XOR of two same value will become 0, and 0 with the odd number of the element with the odd number of occurrences will become that value itself. So yeah, if we don't have to take the XOR or don't have to run through all the array, how can we solve this in a better time complexity? So the first hint, it is given that we need to run it in log of n time, so some sort of binary search or kind of binary search we need to do here. That gives us a hint. Second hint that I get from here is that all the elements appears exactly twice except one, so the overall length of the array has to be an odd number. And third hint is this will be in sorted order. Let's say what happens when we find a middle element. As in case of this example, if we find the middle element 3, we see that there is one element on the left and one element on the right, which are on the left one we have similar value as of right one. What if this was not the similar value? That means we have found our target element, because this is the only element which does not have the neighboring element equals to the same value. So now in this case, if we don't have such scenario, that means the left or right value is equivalent to the mid element, what should be our approach from there onwards? Like where shall we start searching for, in the left half or in the right half? All right, so if you can see from here that if we find that this element is the middle element and this is not the target element, then either we need to go on the right or on the left, based on the fact that wherever the target element is, that side length will always be an odd size subarray. So how does it happens to be true in this case? Let's say we know that this will be of length 4 and this will be of length 4 as well, but as we know that one of these 4 element is equivalent to this element, so in in reality there are actually 3 elements only, and one element this particular fact that this element is equivalent to the middle element reduces the overall size, the actual size that we need to consider here. So this is in fact 3 elements, so we now know that the left half is of odd size, so we need to check on the left half. In this example, we know that there are 3 elements on the each side, but on the left half we know that one of the element is equivalent to middle element, that cancels the odd parity of this subarray, and hence we know that here it was 3 elements and this just next element is not equivalent to 7, so this is our valid subarray where we need to search for. So I have already solved this problem. I am just going to explain how did I solve this. So I used recursion. You can use the regular binary search way of doing it in while loop. So there are certain scenarios like we need to consider spatially when we are talking about the boundary elements, like on the leftmost and the rightmost. So I have taken care of those, although it's not given that yeah, the element will never occur, but I have still taken care of that particular case as well. So now when I have a subarray, I'll take the middle index and check if the middle index happens to be the first index itself. Then check if the second element is not equivalent to the first element. If that's the case, we just need to return the first element itself. Otherwise, if that was not the case, we need to recurse from third element onward, because we know that the first element was not the correct one, or yeah, we have just checked the first two elements and we can simply recurse from the third element onwards. Similar logic goes for the rightmost element as well. Then what I have done is found out the number of elements on the right half and number of element on the left half, and check that if mid element is equivalent to the right element, just right immediate element, then what, as I said, is the actual length will have to decrease. Imagine that this was our middle element. We just calculated out the length of this subarray, then we need to decrease it by 1 if this is matching the rightmost, just immediate right element is matching. So that's what I did. Similarly, I have to reduce the left element, left length. If this is the case, that means the immediate left element is equivalent to middle element. And if this is not the case, that means we have found the element who has both of its neighboring element different than its value, so we should return from there itself. Now once we have found out the number of left elements and the number of right elements, and in that case, as I said in the beginning, we need to find out which particular subarray has equal length of has an odd length size, and based on that we are going to recursively call our function from the remaining half. So I have also taken care of the edge case when we are only given with one element, although it is said that every element appears exactly twice, just in case. And then I've called my function with the initial params as 0 and the length of the array -1. Alright, so this works pretty well. If you guys have any questions, please let me know in the comment section. Thanks for watching this video.